All right, guys, so this is part 2 of the geometry 1 through 22 transformations. We got through 11 problems the first time. I think there's actually 21 problems, but I'm not going to change the name of it so that you can be sure and match it up. So this is part 2 of the video 1 through 22, and we stopped off at how many lines of symmetry does the regular octagon have, all right? So the rest of these go fairly quickly, so it won't be quite as much involved mapping these things out. So a rotation of how many degrees about P would map the parallelogram on itself? Picture it being like a paper with a tack right here. If we were to turn that thing around, at what point would it match itself? And that is, you can tell that if we went 90 degrees, it would be up and down. If we went another 90 degrees, it would map back onto itself. So we're going to call that 180 degrees. All right. So if the heptagon, 7-sided figure, in item 5 were rotated about its center, what's the minimum angle to rotate the figure onto itself? So if we put a tack, if this were a piece of paper and we put a tack right here, how many degrees will we need to rotate it? In other words, that point would need to end up here as we rotated it. So how many degrees would that be? Well, it's 360 all the way around, right? Well, there are 7 points, so we needed to go 1/7 of the distance, or 360 degrees divided by 7. So we're going to call that one S, all right? And double check our answer, and also double checking that I put the answers in this particular review. All right, so how many lines of symmetry does a regular heptagon have? So here we're dealing with the heptagon again. So we have 1 line of symmetry there. We have another one here across through that side, another one here, another one here, another one here. So basically there's one through every single point and the opposite side, but then they start to double up. So however many points it has, as long as it has that line symmetry, that's what we're going to go with. So we're going to go with 7 on that one, C. All right, so what reflection maps the isosceles trapezoid onto itself? Around, there's the x-axis, there's the y-axis. You can see we're talking about folding, okay? We're talking about we're talking about reflecting. So we're actually turning it around. It's like if it was on a flagpole and we just hit it and it turned around, which one would create itself again? You can see that if I flipped it over the x-axis, it would look something like this. The wider side would be at the top, and the narrower side would be at the bottom, and it would look a little bit like that. So the x-axis doesn't work. But if I spun this thing around the y-axis, this is a pole, like a flagpole, and I spun it around, the y-axis would definitely map it back onto itself. All right, so which of the following reflections would match it? So we're going to reflect it across C. You can see that a reflection across C, and it would be the exact same square. A reflection around B, it would be the exact same square. And a reflection around A, the vertical, would be the exact same square. D would not be the same thing if we rotated around there. And E would not be the same thing. So we're looking for the same figure. How many lines of symmetry does a regular hexagon have? We're going to go with 6 because we already did one. And we noticed that every single point, but then this time, there's not a side across from each vertex. Vertexes are the little points on the edge. Instead, we have line symmetry through opposite sides. So we're just going to draw them all until they overlap themselves. So 1, 2, well now I have to mark them so I can keep up with it. 1, 2, 3, 4, 5, 6, and then I'm back to the same one where I started. So we'll go with 6. All right, does a rectangle have the following lines of symmetry? Reflectional symmetry? Yes, it reflects around a vertical line through it or a horizontal line through it. And does it have point symmetry? Yes, it's going to be. It also has point symmetry. If we rotate it around a center point, anywhere we put that point, it's going to be look virtually the same in both directions. And I hope that's right. So this is not number 12, so just ignore the number on this. Which type of triangles can be carried onto themselves by a reflection? Now this one, there's no line you could draw where we could sort of fold it over that line and it would be equal, so it's not symmetrical. We're talking about symmetry, even though it's talking about reflection, because it's very, very similar. If it has symmetry, then it can reflect onto itself. This thing will reflect onto itself. This thing will reflect onto itself. So, isosceles and equilateral. All right. Which is the least angle of rotation that would map a scaling onto itself? So, we need this point to spin around, and at what point would it match where it is right now, and it would fold onto itself? It would sort of recreate itself. With a scalene triangle, you'd have to go all the way around. So 360 degrees, all right? So look, the three statements that are true. The equilateral has 3 lines of symmetry. That sounds right. We've been doing lines of symmetry for quite a while. 1, 2, 3, that sounds right. The scalene has no symmetry. That, I think, is true. No symmetry at all. The isosceles has point symmetry, sure. The equilateral has point symmetry, yes. And I'm going to say the isosceles probably doesn't. If the point P was, I'm a little confused on point symmetry. I apologize. Should have reviewed that. But everybody has little soft places in their knowledge, and even teachers who have been teaching this for a few years. I have some soft places in my knowledge, and point symmetry is not coming back to me right now. But that's okay. That's okay. I'm taking a test, and I'm not going to know everything on the test, but I'm shooting for that, 90, 95%, if not maybe 100%. If point P was at the center of the equilateral of the rotation, 120 would carry the triangle onto itself. That's 1/3 of the way around. It has 3 corners, so yes, I would say that that's true. I'm going to go with all of them on this one. No, all of them except for P and R. The scalene has no symmetry. I guess it does have rotational symmetry if we go all the way around. 360 would have rotational symmetry. It's not true because, I guess it has some sort of symmetry, and the isosceles has point symmetry. That is also not true. All right. So that is the end of that one. That's a little shorter that time. We will move on to one of the other videos here in just a few minutes.